Gentlemen, to chapter 3, lesson 1. I'm going to split this lesson up into a couple different days because it's so important. Order of operations, we should have seen this before, I hope. So what have we done? We've done some pretty simple computation, 2-digit, 3-digit expressions, but now we're going to move into some multi-step problems. We're going to evaluate, focus on the keyword there. Evaluate, fancy way of saying find the final value using the order of operations. And of course, eventually we're going to use order of operations, but there's going to be multiple different formats of numbers. You might see percents, you might see fractions, you might see decimals, you might see all of it. So let's get into it, shall we? Go ahead at this time and title your paper. No matter what the date is, no matter what the assignment number is, title your paper. Come on back when you're ready. Ladies and gents, where do we begin is the question for order of operations. Now look, let's just look at a problem. Jack and Jill were asked to evaluate the expression 3 plus 4 times 2, and yet they got different answers. Jack got 14, Jill got 11. It doesn't really help to have an argument and a wishy-washy answer and say, well, maybe both of them can be right. Look, when you got numbers, when you got quantities, we should be able to agree on the same answer. So that is what the order of operations is built to do. Now, when Jack explained his answer here, he said, look, first thing I did, 3 plus 4 is 7, 7 times 2 is 14. Meanwhile, Jill said, well, I'm going to multiply 4 times 2 first to get 8, and then add 8 and 3. Well, we got to make sure that everybody has the same results. So we say mathematicians have agreed on a set of rules. It really just kind of exists in the nature of number. We just call these rules the order of operations. Now, what I don't want to hear anymore is PEMDAS. Please excuse my dear Aunt Sally. I've heard some people say, look, parentheses are not the only grouping symbols in existence. And how the heck do you do an exponent? See, an exponent is part of a power. Meanwhile, multiply does not come before divide, although I know a number of you, your teachers, have tried to help you and said that it goes from left to right. Add does not come before subtract. In other words, PEMDAS, something for the little kids. Little trick that helps, and it did help you guys back when you were younger. But we need to understand that this is not fully accurate. To start off with, there are not 6 steps, so let's just dig in a little deeper. There really are only 4 steps in the order of operations. The first thing you always do is look for any grouping symbols. Now, yes, I understand you're used to seeing parentheses, but sooner or later, you will furthermore see brackets. You might even see braces. So there are multiple different formats for grouping symbols. After you do any grouping symbols, then you execute any powers involved. Now, remember that a power is any base multiplied repeatedly. It's the exponent that tells you how many, but you can't do an exponent if you just covered up the 2 there. How do you do 3? I don't know. But I do know how to compute 2 to the 3rd power, 2 times 2 times 2. All right, onward we go. What happens when all your powers are completed? Well, then you do multiply or division, and those are equally strong, so they must go left to right in whatever order they are written in. Now, don't go left to right through the whole thing. You don't do any add or subtract until the very end. But again, if you see addition and subtraction both in the problem, they are equally strong. So you go whichever comes first, the first addition or subtraction, and then the next, and so on. Again, don't bring PEMDAS into this house. PEMDA, there are not 6 steps. There are only 4 steps in the order of operations. Therefore, who is correct? We're not actually adding 3 and 4. We're adding 4 groups of 2. And yes, we're not going to write any more of this X business. Let's stick to the dots. You're adding 4 groups of 2, and 3 and 4 groups of 2 does in fact make 11. Therefore, Jill was correct. Onward into some more examples, ladies and gents. So we have grouping symbols 2 plus 9. Close the grouping symbols times 4. Well, you have 4 groups of what? We have to figure out what's in the group. So naturally, we'll do 2 plus 9 first. 2 plus 9 is going to be 11. And then 4 groups of 11, or you could say 11 groups of 4 is 44. Meanwhile, number 5. Now let me go back through the order of operations. I should have written it up here in the corner. Are there any grouping symbols? Nope, check. Are there any powers? Nope, check. Is there any multiplier divide? Ah, yes there is, but remember, these are equally strong. So when we see this, I see a 5 times a 6 and a 12 divided by 4, but wait a second. We have to go left to right. So the product of 5 and 6 is going to be 30. Now don't start subtracting. We have not yet finished any multiply and divide. So what are we subtracting? We're subtracting 12 split up into 4 groups, which is 3. Now that multiply and divide is good. Now we get into any add or subtract. And if there are multiple add and subtracts, we go left to right, but in this case, there's only subtraction. Again, the biggest mistake, some people try to subtract 30 minus 12. We're not subtracting 12, we're subtracting 12 split up into groups. We're subtracting 3. Onward we go. Rewind if you need to rewatch that last part. Now, I would encourage you to pause the video at this point, try to work out the next few problems, and then come back when you're ready. So, number 13, let's just look at the order of operations. Are there any grouping symbols? Nope, check. Are there any powers? Yes. We must do 6 times 6 times another 6. Now, 6 times 6 is 36. 36 times another 6 is 216. If you need to, you're welcome to go off to the side and multiply it out piece by piece. Okay, so grouping symbols, check. Powers, done. Any multiplier divide? Oh, yes, there is. And that, as a matter of fact, there's not one, but 2 different products. So let's go left to right. First thing we're going to do, multiply 12 groups of 4, which is 48. Don't start subtracting yet. We have not yet finished this guy. All right, so now we'll go ahead into 4 sets of 3. 48 sets of 3, excuse me, which is 144. Now that we are done, whoops, my bad. Now that we have completed all multiply and divide, now we get into the finishing touch of addition and subtraction, and in order we get 72. I'm going to go ahead and erase this. Again, if you need to, pause, try to work out this next problem on your own. So what do we have? Grouping symbols. See, I know this is a multiply, but we can't multiply yet. 5 sets of what? So we're going to have to do that grouping symbols first. In fact, 6 take away 1 is 5 sets of 5. Grouping symbols done. Any powers? No powers. Good there. All right, any multiplier? Oh, here we go again. We have a number of different products or quotients. So we're going to have to take all those left to right. In other words, we're going to do 5 sets of 5 first. Now, 5 sets of 5 is going to be 25. Don't subtract. We are not yet finished with multiplication and division. So next up, we again see multiple sets of multiplication addition. Let's do left to right. 4 sets of 6 is 24. Don't do subtract. 24 split up into 3 parts is going to be 8. All right. Now that all multiply and divide is complete, we can get into subtraction. And 25 take away 8 will be 17. So folks, again, don't bring PEMDAS into this house. There's not 6 steps, there's 4. Parentheses are not the only thing. We could have brackets, we can have braces. You can't just do an exponent, but you can compute a power, which is made up of a base and an exponent. Multiply does not come before divide. Those are left to right because they're equally strong. And don't do any subtraction or addition until the very end. I've heard all sorts of things from PEMDAS to joules. I've heard joules. What was joules again? Grouping symbols, exponents. I don't even remember. The point is, you don't need to memorize tricks and gimmicks if you understand order of operations. All right, ladies and gents, so I'm going to give you one last example, and that's going to be a word problem. Take a moment, pause if you want to read this on your own. Come on back when you're ready. I'm going to go ahead and I'm going to emphasize the most important parts. Notice I circled not just numbers, but what the numbers mean. We got 3 field goals. Worth seems like a key mathematical term. Each of those field goals worth 3 points each. 2 touchdowns with extra points worth 7 points each. Write an expression, then evaluate. We got a 2-part problem here. First, we're going to write. Now, 3 field goals, 3 points each. It's going to be 3 times 3. But and also means we're going to put something together. So we're going to add. See, we got 3 field goals, 3 points each, and 2 touchdowns, 7 points each. And so here, ladies and gents, is the first part. We've turned a verbal expression into a numeric expression. Now we're going to evaluate it using our order of operations. Are there any grouping symbols? Nope. Any powers? Nope. Any multiply? Yeah. 2 different multiplies. No. We always start left and then we go right. So 3 sets of 3. Those field goals are 9. Don't add 2. There are no 2 points in this problem. We're not adding 2. We're adding 2 sets of 7 points. We're adding 2 sevens, which is naturally 14. And now we add the points from the field goals together with the points from the touchdowns. We're going to get 23 points total. So that is how you use order of operations for real life problems. All right, folks, I'm going to give you a worksheet for this assignment, or you're welcome to download it online, but most of us will do it in our notebook. In fact, I'm asking you to write your work on paper because when I looked at the worksheet, there's simply not enough space to write your work. So whatever the assignment number is, whatever the date is, go ahead and complete this worksheet using order of operations to evaluate numerical expressions. Take care, do well, and let's grow.